All right, folks, welcome back to another exciting episode where we break down complex concepts into simple, digestible pieces. Buckle up because we're diving into Newton's laws of motion. These laws are the cornerstone of classical mechanics and have a profound impact on our daily lives. We've only got 3 minutes, so let's get straight to it. But don't worry, we'll make every second count. First up, Newton's first law, also known as the law of inertia. This law is fundamental to understanding motion. It states that an object at rest stays at rest, and an object in motion stays in motion at a constant velocity unless acted upon by a net external force. This means that without an external push or pull, things tend to keep doing what they're already doing. Picture this: you're chilling on a skateboard. It's a perfect example to visualize inertia. If no one pushes you, you're not moving. You remain stationary because no external force is acting on you. But the moment someone pushes, you roll, right? That push is the external force that changes your state of motion. That's inertia in action. Simple yet profound. Now, on to Newton's second law. This one is all about acceleration. It explains how the velocity of an object changes when it is subjected to an external force. It states that the acceleration of an object is directly proportional to the net force acting on it and inversely proportional to its mass. In simpler terms, the harder you push, the faster it goes, but the heavier it is, the harder it is to accelerate. The equation? F equals sine ma. This is one of the most famous equations in physics. Force equals mass times acceleration. This relationship helps us understand how different forces affect the motion of objects. Let me break it down. Imagine you have two objects, a car and a bicycle. If you push a car and a bicycle with the same force, the bicycle accelerates more because it has less mass. This is a clear demonstration of how mass and force interact. Simple, right? Now let's move on to the final law. Finally, Newton's third law, the action-reaction law. It states that for every action, there is an equal and opposite reaction. This means that forces always come in pairs. Imagine you're jumping off a boat. When you push down to jump, the boat pushes you up with the same force. When you push down to jump, the boat pushes you up with the same force. This is why the boat moves backward a bit. That's why the boat moves backward a bit. It's a perfect example of action and reaction forces in play. Cool, huh? These laws are not just theoretical, they explain real-world phenomena. To recap, Newton's first law is all about inertia. It tells us that objects resist changes in their state of motion. The second law connects force, mass, and acceleration with F equals sine ma. It helps us quantify the effect of forces on motion. And the third law, action and reaction. It explains how forces always come in pairs and how they interact. These laws are the foundation of classical mechanics, impacting everything from the way we drive cars to launching rockets into space. They are essential for understanding the physical world around us. So next time you're cruising on a skateboard or watching a space launch, remember, it's all about Newton's laws of motion. These principles are at work in every aspect of our lives. Thanks for sticking around, and if you found this helpful, don't forget to like, share, and subscribe. Your support helps us bring more educational content to you. Catch you in the next one. Stay curious and keep exploring the wonders of science.